Welcome to topic 6E, solving quadratics by the quadratic formula, the third method we're going to use for solving quadratics. There is a fourth method. We're not going to do it this year. It's not as widely used. But it is technically the method that gives us this shortcut that you're going to learn today. So the essential question says, how is the quadratic formula used to determine approximate or exact solutions to quadratic equations? Approximate are when we leave the radicals in the answer. No, I scratch that. Approximate is whenever we would get decimal answers. We take everything to a decimal. The exact would be when we leave the radicals in. We are going to be leaving the radicals in today. Next week, when we talk about some real world examples, we'll do some approximations because you kind of have to get some approximations to be able to answer the questions. But today, we're going to be leaving everything in radical form. So if you have a quadratic equation in the general form, ax squared plus bx plus c equals y. So just like factoring yesterday, we're in that form, right? And we complete the square. Now that's the fourth method we're not going to be learning right now. But if you complete the square to solve for x-intercepts, you are left with the quadratic formula. So if we complete the square without numbers, if we just use the a, the b, the c, and didn't put any numbers in, and did all the math for completing the square, what we end up with a formula where we can use that a, b, c to find the solutions. This always works, no matter if it's prime, if it's not prime. It always works. Now, the stuff we did last week when things were in vertex form or they're already in the parentheses with the squared, it is much faster to finish solving by square roots than to try to multiply out something that's in a square with the parentheses and then figure out how the ABC and then plug it into the formula. So one of the things we're going to prompt you, since we're in this distance learning environment this year, we're going to prompt you the best methods to use as we start doing more practice next week in solving. But for now, whenever you're in the factoring section of the homework, make sure you factor. And then when you're in the quadratic formula section, make sure you're doing the quadratic formula. We want you using the method that we're teaching because you got to master all the methods. So here we go. The quadratic formula. Now, there is a little story that I'm going to tell you as we go through and hear the quadratic formula for the first time. I did not make up the story, but this story helps some people memorize the quadratic formula because the quadratic formula is just one of those things you've got to memorize. So this is how the story goes. The story goes like this. There once was a negative boy, so that's a negative b, who was all mixed up, plus or minus, because he was all mixed up. So he went to a radical party, so square root here, right? That's another word, radical is another word for square root. But because he was square, so the boy was squared, so it's b squared, he lost out, so minus because he lost out, on 4 awesome chicks, 4AC. So he cried his way home, and when the night was all over, so we're going to say it's all over, we're going to put a fraction bar on the whole thing from the negative b all the way to the end. It was 2 a.m., so 2a. So this is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over, we always call it all over, 2a. If we were in class, I'd have you do this along with me. I also know you can sing this to Pop Goes the Weasel. So I will sing it for you. All you APA people, no judgment. I can't hold a key very well. But here we go. So if you sing it, it's another way to memorize it. You've got to memorize it. So by singing it in class, sometimes that helps us memorize this formula. It's one of those things you just got to commit to memory somehow. So if you're going to sing it, you would say x equals negative b plus or minus radical b squared minus 4ac all over 2a. So there you go. Pick a method, just straight up memorize it however you like, but you got to get it memorized. I would highly suggest before you start your homework, you write it down again on your paper. I'll probably have a prompt you a place to put it, that you're constantly writing it every time you do the problems until you've got it kind of memorized, because it's one of those things you just got to get memorized. So to use the quadratic formula, the quadratic equation must be set up the same way as when you solve with factoring, which means you're going to set y equal to 0. So it's that same thing, right? Quadratic the square roots. No matter what you're solving, we're solving for x-intercept. So y is always, always, always 0. Then you make sure the resulting quadratic is set equal to 0. So equal to 0. And in standard form. So it needs to be set equal to 0 and in standard form before you can start identifying the A's, B's, and C's. All right, so to use the quadratic formula, the quadratic equation must be set up the same way as when you solve for factoring, which means you set y equal to 0, then you make sure the resulting quadratic is set equal to 0 and in standard form. So that's the key. Y equals 0, and then make sure that it's in standard form. So here we go. Very similar to what we're doing with factoring. And then we just got to identify our ABC and plug into the equation and solve. So here we go. We have x squared. I'm going to make this a little bit bigger here since we're just doing the problem. I might have to move over a little bit. We'll see. Quadratic formula takes a lot of space on your paper. It's not super hard to do, but it takes a lot of space. Give yourself the space. Get some extra paper. You're better off showing all the steps in the work and doing the space to get to the answer correctly. So we have x squared minus 2x minus 8 equals 0. So we've already been identifying A, B, and C from when we were finding vertex, which, think about it, vertex is what? Negative b over 2a. So if you look at the vertex is everything in the quadratic formula minus the plus or minus radical part, right? So the negative b out front and the 2a on the bottom, that's part of the quadratic part of the quadratic formula is how you find the x-coordinate of the vertex. It's all interrelated. All right, so a is 1, b is negative 2, c is negative 8. Don't forget the negative signs if they are negative. So then we go over and we just plug in to the equation. Just like when we were doing the vertex, I will plug in, put the numbers in parentheses, and not do any math until I write the whole problem out first. So I'm going to have x equals, it's negative b, so it's negative 2 plus or minus the square root of negative 2 squared, so put that negative 2 in parentheses, minus 4 times parentheses 1 times parentheses negative 8. Right? And then the whole thing is going to be divided by 2 times parentheses 1. So I put all of my letters, my A, B's, and C's, in parentheses to show that multiplication. I don't do any math. I don't do any simplifying or any math. That's just my personal preference. That way I don't start making mistakes. And then we'll start doing some math, right? So negative 2 means that's a positive 2 out front. Plus or minus. This plus or minus should look kind of familiar too, because when we were doing radicals, right, all of our answers had plus or minus. We had to do the plus or minus square root 36, plus or minus square root 100. It's the same principle here. We have to do the plus or minus, the same exact reasons. Negative 2 squared is 4. And then negative 4 times 1 is negative 4. Negative 4 times negative 8 is positive 32. So I usually do the squared, and then I do the negative 4 times A times C, which is positive 32. We're going to divide this whole thing by 2. So here we go. Now I'm going to simplify the notes under the radicals. So I have 2 plus or minus the square root of 36, all divided by 2. Now, if you remember, back in our unit 4, when we did our radical work said the only way radicals can go away is if we can take perfect squares out from underneath them, right? Only way things can come out from under a radical, right? We cannot divide 2 out of 2 and 2 out of square root 36. So the square root 36 is like a thing in parentheses. Things can't come out of it unless it comes out by the radical rules. But before we do that, we should always simplify our radicals. So square root of 36 just happens to be a perfect square. So this becomes 2 plus or minus 6 all over 2. So if it's a perfect square, that's awesome. It makes it much easier for us. Most of our answers are probably not going to be perfect squares, but we'll have some. Right, so here we are. Now I need answers, just like when we were doing square roots. We need to get 2 x values. So we need to do the math to figure out the 2 x values. So one of my x values is going to be x equals 2 plus 6 divided by 2, which is 8 divided by 2, or 4. So one of my x's is 4 because we did the plus sign first. And then we need to do the minus sign. So then I have x equals 2 minus 6 over 2, which is negative 4 over 2. I'm going to move this over a little bit so I have enough room, which is negative 2. So that means my x equals negative 2 comma 4. Right? Because there's a plus or minus here, right? Because there's a plus or minus here, we need to do the plus and then we need to do the minus because we need to get both answers, both of them. Okay. All right. So plug into the formula first. Right. Make sure you can plug into that formula and then just start simplifying, and keep simplifying until we can't simplify any further. All right. Let's come down here and do number 2. All right. So first thing we need to do is set y equal to 0. So we have, whoops, what are we moving? We're moving, so let's try this again. So 2x squared plus 4x minus 7 equals 0. So my a equals 2, that's what's in front of the x squared. My b equals 4, that's in front of the x. My c equals negative 7. So let's plug those in to my quadratic formula. My quadratic formula says negative b plus or minus square root b squared minus 4ac all divided by 2a. So I'm going to do x equals negative b. So even when my b is positive, I usually put in parentheses to start with, just for consistency's sake. Square root of parentheses 4 squared, b squared, minus 4 times a, which is 2, times c, which is negative 7, and divide that whole thing times 2 times a, which is 2. So there we go. Negative 4 plus or minus the square root of 4 squared minus 4 times 2 times negative 7, all divided by 2 times 2. Now I'm going to pull over here a little bit because I got room here to the right. So we're going to lose our ABCs, but that way I can keep working this way. All right, so simplifying. I have negative 4 out front, plus or minus the square root of 4 squared is 16. Negative 4 times 2 is negative 8. Negative 8 times negative 7 is positive 56. So here we are. That's what's under my radical now. And then 2 times 2 on the bottom is 4. All right, so that's usually my next step, is to get things in the radical simplified. So 56 plus 16, come down here. So I have negative 4 plus or minus the square root of 16 plus 56 is 72. And then I divide that whole thing by 4. Now looking at 72, 72 is not a perfect square. And so we need to factor 72. So I'm going to go over here to the right on my paper here, and I'm going to factor 72 because we need to simplify the radical, right? Just like we learned how to simplify radicals in Unit 4. So I have 2 times 36. I have 2 times 18. I have 2 times 9. And then 9 is 3 times 3. Right, so if I was going to write this as a radical, I'd have 1, 2, 3 2's. So 2, 2, 2, and then 3 3's, or 2 3's, sorry. So I have a group of 2's that gets to come out. That's 2 stays underneath. And I have a group of 3's that gets to come out. And 3 times 2 is 6 square roots of 2. So my square root of 72 simplifies to 6 square roots of 2. We got to simplify it. So going back over here, I have equals negative 4 plus or minus 6 square roots of 2, all divided by 4. Now this one has a radical left in our answer. It's okay if there's a radical in our answer. We just need to make sure everything is still as simplified as possible. So the last thing we need to check is that we need to see if there's anything we can divide out of all of the terms. So what we need to look at is we need to look at these 3 numbers, all 3 of them. If all 3 of those numbers have a number other than 1 as a GCF, we can divide it out. So let's make a note of that right here. So look for GCF of all. Has to be all 3 numbers. Right? If there's not a number there, it's a 1. If there's not a number in front of the radical, then the number is a 1. So that would be that the GCF would just be 1, right? So for all 3 numbers, to simplify fraction, because we want to make sure our fraction's simplified as much as possible. And then just remember, another note here, I'm going to put in parentheses, nothing, underline it twice, can divide out from under a radical. Right? So that what's under that radical stays under that radical no matter what. Once we've simplified the radical, that radical stays there. The radical does not change. Like the only way a radical can change is if you can simplify it further. All right, so we're just looking at the coefficient of the radical, the b that's out front, and the number that's on the bottom. Those 3 numbers. If those 3 numbers have a GCF other than 1, then we should simplify those fractions. That's like 3 fractions we're simplifying at one time. All right, in this case, I'll change to purple here, right? We can divide out 2 from 4, 6, and 4. So my final answer is x equals -2 plus or minus 3 square roots of 2 stays exactly the same because nothing can change, divided by 2. And we don't have to find the plus and the minus because the radical's there. We can't, unless we put it in a calculator. If you put it in a calculator, then we can get a decimal approximation for this answer. We're not going to find decimal approximations today. We'll do decimal approximations next week. For now, I want you to focus on giving me the exact answer, which has the radical. So the answer to this problem is x equals -2 plus or minus 3 rad 2, all divided by 2. So we got to check those 3, got to check these 3 right here. And if those 3 have a GCF other than 1, simplify it. But we get to leave the plus or minus. We don't need to write it out as 2 separate answers. We don't have to write out -2 plus 3 rad 2 over 2, -2 minus 3 rad 2 over 2. We don't do that. That's a waste of space. We only have to figure out 2 whole numbers. If all the things are whole numbers like they were in our square roots. When we were doing square roots last week, I only gave you whole number problems, answers, perfect squares. Technically, the square roots last week could end up with answers 3 rad 2. You could have done -4 minus 3 rad 2 or something, like a plus or minus 3 rad 2. That could have been an answer last week. We just didn't give you any of those. Okay? All right, there we are. But that's 2 problems. We have, I think, 2 more to practice here to make sure that we can do this. So let's do 2 more. Flip the page to page 10. Here we are, page 10. So let me go back to I like to start with blue. I'm going to make this bigger here. All right, so this one does not have a y that's equal to 0, but it also, again, does not have everything in standard form, right? It has to be equal to 0, right? So we need to be equal to 0. So needs to equal 0, just like with factoring, same process. So we have 4x squared plus 5x plus 2 equals 0. Once we have it equals to 0, then we can use the quadratic formula, right? So then we identify our a. So our a equals 4. My b equals 5. My c equals 2. Right, there we are. So once you have it in standard form, everything on one side, you identify your ABC, we plug into the quadratic formula. Let's go ahead over, I'm going to move the paper over here. I'm going to write the quadratic formula again up here on this page. So it's x equals -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now, we are in distance learning right now, so technically you're allowed to use your notes on your test so you can look at this. But if you're able to commit this to memory, you're better off because when you get into Algebra 2, you're going to have to use it memory. You're not going to be able to use your notes probably. So making sure you can memorize this is one of the things that is a good thing to be doing this next 2 weeks. All right. here we go. Let's go back over to here so I can see my letters. So we have x equals negative 5, there's my b, plus or minus the square root of b squared, so that's 5 squared, minus 4 times a, which is 4, times c, which is 2, all divided by 2 times a, which is 4. So here we are plugging directly in to the quadratic formula. All right, maybe I'll just go down below for this one. So then equals negative 5 plus or minus the square root, so 5 squared is 25. And then 4 times 4 is 16. 16 times 2 is 32. So it's a minus 32. Because it's a negative 4 times 4 is negative 16. Negative 16 times 2 is negative 32. And then 2 times 4 is 8 on the bottom. Okay, now we got to simplify what's on that radical. So it's the same kind of steps and process every time. Negative 5 plus or minus the square root. 25 minus 32 is negative 8 divided by 8. All right, we hit this point in the problem. We should be, some red flags should be flagging off for you, right? We have a negative under the radical. If there's a negative under the radical, right? So negative under radical, then we should already have the answer, right? We stop working. The answer is no real solutions. This has no x-intercepts. It does not cross the x-axis. So no real solutions. So just like with square roots, right? You can't have negatives under radicals. So there's no real solutions. This is one of those problems with no x-intercepts. So if you're doing the work and you get to that negative under the radical, then we stop and we write no real solutions. Okay? All right, one last problem. One last one we'll do together, and then you have homework to practice this stuff. Don't forget to make sure you're checking your answers when you do your homework. Make sure you're doing them right. All right, here we go. This one has a y, so let's set that y equal to 0 first. So 6x squared minus 10x minus 8 equals 0. Now, when we're using the quadratic formula, before we start to use the quadratic formula, we should check for GCFs. Taking the GCF out is going to make the math way easier. And so that is something we highly recommend. Technically, you'll get to the answer if you leave the GCF in, but it's just going to be a lot more math. And who wants to do more math than you have to do, right? So before you use the quadratic formula, check for GCF to make math easier. Sometimes the problems can seem almost crazy hard. And then you take the GCF out and you're like, oh, this is a super easy problem. So taking the GCF out, take GCFs out first, factoring or quadratic formula. Just take them out because we don't care, right? They don't matter for factoring. That number out front doesn't matter for quadratic formula. Sometimes you take it out and you might notice, hey, this is an easy factorable problem, and then you can just factor it. And sometimes you take it out and say, this problem still looks a little crazy. Let's use the quadratic formula. So we're going to do that. So let's take out, in this case, a 2, because we can take 2 out of all of these. 2 comes out front, and then it's 3x squared minus 5x minus 4 equals 0, right? So now we're just going to do the ABCs with the quadratic that's left in parentheses, right? So again, we get to ignore. So we get to ignore the GCF when we're solving. It has other uses. There are other things that we need that number for out front. So it's not like we're ignoring it for all of quadratic stuff, but in terms of solving quadratics, we get to ignore it. We take it out and we let it hang outside and we don't have to worry about it. So let's look at this problem. So we have A equals 3. We have B equals negative 5. And we have C equals negative 4, right? So there's my ABC from inside. So let's plug in. X equals -5, negative b, plus or minus the square root of -5 squared minus 4 times 3 times -4, right? So it's b squared minus 4ac. We call this inside the parentheses the discriminant. I did not put that in as vocab. I should have maybe put it somewhere as vocab, but it is called the discriminant of the quadratic. But I'm not going to make you memorize that this year, so I'll just give it to you once. So, and then divide by what? 2 times a, which is 3. Okay, so there we are. There's our quadratic formula. I'm going to scooch this way so that way I can keep working. So negative means that's a positive 5. So it's 5 plus or minus the square root. -5 squared is 25. -4 times 3 is -12. -12 times -4 is a positive 48. So that means we're going to add 48 inside. 2 times 3 is 6 on the bottom. All right, so then I have equals 5 plus or minus 25 plus 48 is 73. So we have the square root of 73 divided by 6. And the square root of 73 cannot be factored, right? I think 73 is prime. Can't take out a 2, can't take out a 3, right? So it cannot be factored. So if it can't be factored, then we're done, right? Because this is a 1 out front of here. So we have a 5, a 6. So if we're looking at, remember we said we had to look to simplify. If we're looking at the 5, the 1, and the 6 here, right? The GCF of those is just 1. It's always just going to be 1 if there's a 1 in front of that radical. So that means my answer is x equals 5 plus or minus square root 73 over 6, right? We were done. If you get a non-factorable radical, then you're done. Problem's over. There's my answer. X equals plus 5 plus or minus square root 73 over 6. All right, so that's using the quadratic formula. It takes a little bit of space in your paper, not ridiculously hard, but you got to be super organized. And you got to make sure you're following all your math rules. Do one thing, kind of how I showed you, plug everything in, do that stuff under that radical next, then see if your radical can be simplified, right? So there are things you got to keep doing to get to the final answer. So good, fun practicing this week. Wednesday, we'll do some practice in class to make sure you've got this stuff down. And if you have questions, make sure you bring them. Talk to you guys later. Bye.